Hey Maths Wizard! In the previous video, we discussed some really interesting problems on parallelograms and saw how proper application of their properties helps us solve problems so much faster. Now, to be able to employ the right approach to solving a problem, it is imperative that we indulge in constant practice. Knowledge is of no value until we put it into practice. This isn't my quote, it is actually the quote of one of my favorite short story writers, Mr. Anton Chekhov. He was so correct, wasn't he? So it's time we put our recently acquired knowledge to practice and see how well we have grasped them. So, ready to challenge yourself? Let's roll. The questions we are discussing today may seem a little tricky, so I request your undivided attention. The first one states that diagonal AC of a parallelogram ABCD bisects angle A, and we have to show that AC also bisects angle C, and B, ABCD is a rhombus. Now, the question seems fairly simple, but let's try to understand the requirements better using a diagram. This is where you have to be smart and draw a rhombus instead of a general parallelogram, because the question itself asks us to show that ABCD is a rhombus. Now, you may be wondering what would happen if we draw ABCD as a general parallelogram. Nothing really, just that drawing it as a rhombus will help us visualize better, and if we can visualize better, we can apply better. So, as per the question, there's a parallelogram ABCD where this diagonal AC bisects angle A. That is to say, this angle is equal to this angle. Now, we need to prove that this diagonal AC also bisects angle C. Or in other words, this angle is equal to this angle. So this is the first requirement. The question also asks us to show that ABCD is a rhombus, which means we also need to prove that all the sides of this parallelogram are equal. So now that we know what the exact requirements are, how do we approach this question? Let's explore. Well, one way to go about it would be by proving that these two triangles are congruent, so these two angles, being the corresponding parts of congruent triangles, would naturally be equal. So, mathematically, in triangles ADC and ABC, AD is equal to BC, because if you notice, they are just the opposite sides of a parallelogram, and as per one of the properties, they must be equal. So, following the same property, DC is equal to AB, and then AC is equal to AC because it's common in both the triangles. So, side, side, side. Thus, triangles ADC and ABC are congruent by the SSS criterion. Then it's easy to conclude that angles DCA and BCA are equal because they are just the corresponding parts of congruent triangles. Wait a minute. Are they really corresponding parts? Well, if we place the triangles side by side, we'll be able to see that the angle corresponding to angle DCA is actually angle BAC, not angle BCA. So we can't really say yet that angle DCA is equal to angle BCA. Whoa! Saw how tricky it got? We almost thought we got it. No worries though. We just found a way of not solving such a problem. I'm sure you've heard about Thomas Edison. He is famous for never giving up in search for the construction of an electric light bulb. He once said, and I quote, "I have not failed. I've just found 10,000 ways that won't work." We made this mistake only to be sure not to make it again. So now, let's change our perspectives a little and try a different approach. We have seen in the previous video that while solving problems on parallelograms, some properties of angles formed by parallel lines and transversals come into play. This is actually very common because if you think about it, parallelograms are essentially figures made of just parallel lines and transversals. So you must always be prepared and on the lookout to use those properties appropriately. Coming back to the question, how do we prove that this angle is equal to this angle? I told you to always let the question guide you. So let's begin with what the question tells us. It tells us that this angle is equal to this angle. So if we assume that this angle is x, naturally the other angle would also measure x. Now we know that in parallelogram ABCD, opposite sides AB and DC are parallel, which means AC acts as a transversal between them. Then this angle would be equal to this angle because they form a pair of alternate interior angles, which as we already know are equal. Thus, this angle also measures x. Similarly, these two angles also form a pair of alternate interior angles, so this one also measures x. There you have it. We just proved that this angle is equal to this angle, which means diagonal AC bisects angle C. The first part of the requirement is met. Now, if you notice, angle A measures 2x and angle C also measures 2x. So unknowingly, we just proved the property that in a parallelogram, the opposite angles are equal. This indeed was a good approach. I'm sure you would agree. Let us now advance to solve the second part of the question. We need to show that all these sides are equal. They already look equal, don't they? It's because we got the diagram right. Now, if we look at triangle ADC, two of its angles are equal, so we can say that these two sides AD and CD would also be equal, because in a triangle, sides opposite to the equal angles are equal. So, following the same property in triangle ABC, AB and CB being opposite to the equal angles are also equal. So, we proved that these two sides are equal and then these two sides are equal. But how do we show that the other two pairs are also equal? I'm getting this feeling that we can apply a property here. But which one? Something to do with sides. Bingo! The property on opposite sides. We know that in a parallelogram, the opposite sides are equal, which means AB is equal to CD and AD is equal to CB. But we have already proved that AB is equal to CB and AD is equal to CD. So, using all these pairs of equal sides, we can finally infer that AB is equal to CB is equal to CD is equal to AD. Or in other words, ABCD is a rhombus. See, both parts of the requirements are met, so the problem is solved. That wasn't too difficult, was it? I'm glad you are getting the hang of it. Let us now solve another question. This one states that ABCD is a rectangle in which diagonal AC bisects angle A as well as angle C. Now we need to show that ABCD is a square and B, diagonal BD bisects angle B as well as angle D. Now the question does not need an explanation, right? So let us just proceed to draw the diagram. Here too, it will be wise to draw a square instead of a typical rectangle. We saw how getting the diagram right helped us in the previous question. So let's just do the same for this one as well. So, as per the question, ABCD is this rectangle where this diagonal AC bisects angle A, which means these two angles DAC and BAC are equal. AC also bisects angle C, which implies that angles DCA and BCA are also equal. Now, we need to show that this rectangle ABCD is actually a square, or in other words, all the sides are equal. Now, if you think about it, this question is actually a close relative of the previous one. There, ABCD was a parallelogram and we proved that all its sides are equal. Here we have a rectangle instead, but the requirement remains the same. All the sides are to be proved equal. We can use the exact same steps as we did in the previous question. We can see that these two angles are equal because they form a pair of alternate interior angles. Similarly, these two angles are also equal because they too form a pair of alternate interior angles. Now, in each of these triangles ADC and ABC, sides opposite to the equal angles are of course equal. So now, using all the pairs of equal sides, we finally arrive at AB is equal to CB is equal to CD is equal to AD. Therefore, ABCD is a rectangle where all the sides are equal. That is to say, ABCD is a square. See, we got the first part already. Now, for the second part, the question asks us to prove that diagonal BD bisects angle B as well as angle D, which means we need to prove that angles ABD and CBD are equal, and so are angles ADB and CDB. But how do we go about that? Since we need to prove that these two pairs of angles are equal, wouldn't it be wise to just prove these two triangles congruent? It would be, because then these two pairs of angles would naturally be equal as they are just the corresponding paths of congruent triangles. So, mathematically, in triangles ADB and CDB, AD is equal to CD and AB is equal to CB because ABCD is a square and the sides of a square are equal. Also, DB is equal to DB because it's common in both the triangles. So, side, side, side. Thus, triangles ADB and CDB are congruent by SSS criteria. Then it's easy to conclude that angles ADB and CDB are equal, and so are angles ABD and CBD because they are just pairs of corresponding paths of congruent triangles. Now, if you remember, we tried to use the same method in the previous question, but it did not work there because we had not proved until then that all the sides are equal. So we couldn't prove the required angles equal that way. Here, we have already proved that all the sides are equal, which is why we can easily say that the required angles are also equal. So now, it's pretty evident that since these two angles are equal, BD bisects angle B. And since these two angles are equal, BD bisects angle D as well. See, we just proved both the paths of the problem. So, we can safely say that we nailed it. Whoa! This too was a long video, but I'm sure that you found it informative. We saw some more applications of the different properties of parallelograms. And we also saw why knowing the different properties of angles between parallel lines and transversals is important. We never know when they may come handy. I'm glad we have laid a solid foundation. Just a little more practice and you will be ready to take on the questions all by yourself. It is important though that you retain all that we have studied today. So, if it helps you, go through the video once again so that you are absolutely ready for the next one. Till then, take care and keep practicing.